Hello everyone, next lecture of product realization technology. So from this lecture onwards, we will be talking about manufacturing processes. Okay, so we have learned what are different engineering materials, manufacturing materials, and one thing you must have understood is based on the properties of these materials, they can be processed using different techniques. Something can be heated, something cannot be heated or melted, and things like that. Something can be processed only in the powder form, and so on. So now all of these processes, the entire set of these processes, which are used to convert a raw material into a product. And here we are talking about tangible product, something you can touch. So all these processes are known as manufacturing processes. This is not very complicated, right? Okay. So now, like everything else, we can also classify manufacturing processes. The standard way of doing this is primary and secondary, and nowadays there is also this another term involved that is known as advanced manufacturing processes. So anyway, primary and secondary are important for this particular course, maybe some advanced processes as well. Okay, so what is a primary manufacturing process? So you can understand from the name that it is something which directly deals with the raw material. What is raw material, by the way? It's something that is, let's say I give you 1 kilogram of iron and I ask you to make some machine part out of iron. So that 1 kilogram of iron, that is your something that you start with, that is your raw material. You may have to work on it multiple times before you can, or use multiple manufacturing processes before you can get to the final product. Okay, so these processes, which basically they give the first shape or initial shape to the raw material, those are known as primary processes. Okay, so you can think of an example. You melt or you heat you can take red hot iron and then you hammer it. What will happen? You must have seen this kind of process, right? So if you hammer any heated metal, then it will change its shape. So that is something very, very primary. You start directly with the iron and you have this, hammering is your manufacturing process. Okay. What will be the secondary process? Of course, then once you have an initial shape that came out of your primary process, you know that that is not your final shape, right? That is your initial. So after hammering, maybe you need to perform some surface polishing because there may be also some defects in the material, so you may have to remove those defects. Maybe you need to protect your iron part from rusting, so you need to polish it. So there will be all of these things. Also, one more thing is that if you want to make something that is let's say 10 centimeters in size, but you have it 12 centimeter. When you are making it, maybe you don't have that much control and what you get is not 10, it is 12 centimeters. So what you need to do is you also need to remove the material. Now, typically this will not happen that 10 centimeter part is 12 centimeter. Rather, it will be just a few millimeter up and down. And that millimeter, those margins are known as tolerances. I think this is something we have also discussed in the previous lecture, but I would like to mention it here that the margins, the extra little bit of extra material that is allowed or little bit of deviation from the actual dimensions. It doesn't have to be always a couple of millimeter more. It can also be a couple of millimeter less. So you have this plus minus 1% or 5% or 10% deviation that is acceptable. That is known as the manufacturing tolerance. So to bring the part within the tolerances, also you will need to perform certain operations. For example, filing is one thing which can remove some material from the surface to reduce its dimension. Also it can make the surface smoother. So here also another example I have given, we talked about ceramic abrasive materials. Sometimes with abrasive slurry also we perform the finishing of the surface. So all of these actions, all of these processes are known as secondary processes. Okay, now the third one, as I said, advanced manufacturing. So advanced is again a terminology which is used for anything that is new, and there are a lot of processes nowadays that are a combination of both primary and secondary. In that sense, you don't need to perform additional polishing of the surface, or you already get a very smooth structure. You may even have for example, sometimes you have to drill holes into something because you want to attach it to another part. Now in these advanced processes, sometimes you get the structure already with the holes. So they are defined holes, or they are already in the design itself. For example, 3D printing. So in the 3D printer, whatever, even if you want to make a hollow structure, no matter what do you want to make, you can already give the design, and the product that comes out will already be ready for the next step or already be a finished product. So these kind of processes are known as advanced manufacturing processes, and in general, many unconventional processes. So all these things which you are going to perform in the workshop, most of them are traditional processes, but whatever is unconventional, typically we use the terminology advanced. Also, advanced in some cases can mean that these are computer aided machines. So you basically feed a design, some sort of CAD design into your system, and then the system itself can provide that design. So there is less manual labor and more dependence on technology. So all these kind of processes are known as advanced manufacturing. Okay. Now, I told you that we start with raw material when we work with primary manufacturing process, but sometimes there can also be certain things that are performed even before the primary operations. For example, if you have an ore, and ore need to be, let's say you have a carbide or sulfide of a certain metal and you need to process it to get the metal itself, that is an operation that has been performed beforehand. So you already start working with some sort of stock of your, or sometimes in the case of polymers and so on, you need to prepare an initial stock, initial lump of the material before you start even the primary operations. So those things also are possible, and in some textbooks, in fact, this is the reason I mentioned it here, in some textbooks, those operations are also included in the primary manufacturing operations. I have not included them because they are not really related to manufacturing, and that is why you can, in any way, you can also call them primary operations. Now, one more important thing, I told you that when you make a part, let's say if you're trying to make some electronic device, so you will prepare different parts and join them, assemble them together, right? Because you have a different materials for designing the circuitry. You can have some PCBs, you can also have different types of cables and some semiconductor chips maybe, and then you also have a plastic cover, a casing around it. So there are different types of components, even made of different materials, they are assembled together. So you have to make them differently and then perform what is known as either joining or assembly operation. So when we say joining, then we are rather joining them such that they don't they don't come off easily unless we intentionally want to remove them from each other. Certain joints are also permanent joints. For example, welding, we will come to it. But certain joints, like with nut and bolt, you can open them, so they're removable joints. But assembly is something where you're not really, you're never making a permanent joint. You're just putting things together that can be disassembled at a later stage. So often when you make the part, after that you have to integrate, put together these different parts. These things are known as joining and assembly operation. Okay. So now in some books, again, joining is considered as primary operation, some secondary operation. The point is, if after joining operation, you need to still go for some more processes. For example, let's say you perform welding, but after welding, if you need to give, another smoothening to the surface, right? So if you have to perform one more operation, then in that case you can call this as primary operation. Also, it depends on where did you start? Did you start all the way from the raw material, or somebody just gave you two parts and asked you to weld them together, join them together? So depending upon all these factors, you can call welding primary or secondary. In general, in this particular course, I'm going to call all joining operations as secondary operations. Okay. Fine. So this is what I have also mentioned here, that everything cannot be, you cannot have the same definition of all manufacturing processes, but you need to understand which processes you are, when are you directly working with the raw material and when you're working with already prepared parts. Okay. All right. So let us start with our first manufacturing process, and that is casting. In the syllabus, I had written machining first, but let's start with casting. This is something very interesting. You know the idea of casting? Shaping any liquid material. And in most cases, this is used for metals and alloys. So, in fact, in some old textbooks, casting is also called metalworking. So, it is mainly for metals. Why? Because these materials can be melted at high temperatures and then they can also very easily solidify again, and they can even crystallize again, even though they give you a polycrystalline shape, but they crystallize again. So this idea, pouring a molten metal into a mold, and then after the solidification of that shape, then you remove the mold. This idea is known as casting. Okay, so what will be the steps involved in casting process? Of course, there will be some steps before that, some after that, but in the casting regime itself, you will have, first you have to melt the metal or material, but as I said, it's in most cases metals or alloys. So melt it, and then in parallel you also can prepare a mold. Now I have written some terms here. We are going to learn about these, the entire terminology in this slide and the next one as well. You prepare a mold with what is known as a pattern cavity. So when I say cavity, you already know that there is some empty space, like you have cavities in your teeth. So it's a pattern cavity. Pattern basically means that you have a certain shape, whatever shape you want to make, that is what you will call as a pattern. And then you will have a cavity in the shape of your pattern inside a mold. So that is what you need to do. You need to prepare that mold. Then you pour the liquid metal into it, and then of course you let it solidify, and then you remove the mold, get rid of the mold. This is basically, these are the steps involved in the casting process. But these steps, I mean, this is something in the simplest terms I have mentioned, but there may be some technical aspects that we are going to learn in this lecture. So here is what I have just said. This is the part, let's say you want to make, and by the way, this is a complicated shape, and this is also a 3D shape. I don't know if it looks like a 3D shape in this slide, but this is what you want to make. Now, if you want to make different parts and join them together, this is going to be very complicated. So usually for these kind of complicated shapes, intricate shapes, that is where you use casting. Okay, also you want to minimize the number of joints there. So this is what we want to make. So what do we need for that? I told you we need a mold, and I'm showing this mold in two parts with this cavity inside. So this white space, basically the empty space, that is of the same shape as the final part. And how did I get that? I got this using, somehow I must have prepared that mold, right? So how do I prepare the mold? I need what is known as a pattern. That is why I use the term pattern and pattern cavity. So you prepare something, some initial structure. Usually you would use a metal or a wood or something like, so you want to make it little bit stable. That is your pattern, initial pattern. Now, if you want to prepare a mold out of sand, in most cases molds are prepared out of sand. So it's a little bit of sticky sand. It's, I will talk about the composition of that sand also, but it's mostly sand with some clay and some additives. It can bind very well. So what you do is, now you fill one box, let's say the bottom box, with sand, put your pattern on top of it such that half of the pattern comes out of the sand. And then you take another box, fill it with sand, and put it on top of it. So put it like this, like you close a box. Now what will happen is, inside the box you have this pattern, and now you have the sand which is nicely packed. Once the sand is very nicely packed such that it does not, it immediately does not go off, then in that case you can now very slowly open your box, remove the pattern, and put the thing back, put the box back. So this is the idea. This is how you create a cavity. Okay. Now after that you will pour some metal into it, and then the metal solidifies, and now you will have your, then after that it's a sand mold, so you can just remove it afterwards, after the solidification. But do you see any problem here? One problem all of you must have noticed is that, how do we pour the metal? So pouring the metal requires some sort of channel, right? There should be some cavity, some channel through which you can pour the metal. Okay, and also there can be some other channels where the displaced air or displaced material can go. So there should be also some cavity on the other side. Otherwise you will never be able to pour the metal. So this basically is an incomplete design. Okay, fine. So we are going to have to learn about the complete design in the next couple of slides. But before that, let me just, whatever I have written here, the names of these things I should explain. Pattern is your initial structure that is used for making the mold. Of course, you can use it for making multiple molds, right? So that is why I'm saying that this should be made of wood or metal or something like that, because the master pattern is can be used for making multiple molds, and in fact it is used. Okay, so this is basically, as you can see, that the shape of the pattern is exactly as that of the final part, right? But the mold itself carries the negative pattern. Okay, so yeah, this is made of stable material, and mold is of course the second image that you see here. So mold is this structure which contains the pattern cavity. What is the mold made of? Refractory materials. Sand is a refractory material, and any refractory material is anything which can withstand very high temperatures without being, of course, without being degraded, and also without expanding thermally. So with minimum possible thermal expansion coefficient. So that is what you use. You also have refractory metals. You can also make this using graphite. But mostly, the most common mold material is sand, and then sometimes for a little bit sophisticated molds you can use also plaster of Paris and these kind of ceramic materials. Okay, so pattern and mold, and yeah, so mold always has this cavity through which the material is poured. So these are basically the primary components. This is just to give you an idea of what is casting, but as I mentioned, this is an incomplete design. So now we come to the complete design. Here it is. Same structure. You see in the center, I have written, or not exactly in the center, but there is the mold cavity, the same mold cavity that you have. But now on both sides, I have prepared some channels. These channels will, so the first one where I have written pouring, you will pour the metal through the first channel. It will go, and it will then somehow, at some point, it becomes very narrow, that place, that is what I have called gate. I've written it as gate. Gate is basically just the gate or the door to your structure. So just before reaching the final structure, that the channel becomes narrow, and that is what we call as gate. So now your metal goes through the first one is called sprue, the main channel through which you pour the material, and you can see that this is little bit, it's wider on top, because of course you need to pour melted metal. So this is a wider channel which becomes narrow, and then it goes through what is known as a runner, which directs your metal to the structure, and then very close to the structure it becomes very narrow, or relatively narrow, and then this is called a gate. On the other side of the structure, you again see a little bit of narrow passage, and then you again see some channel which takes the material sort of out of the mold. That is known as the riser. And why is it called riser? We will learn. So these are some of the definitions. Now, whatever is you can see in this picture, few other things, scope and drag. So I told you that these what is it called? The mold is made in two parts, right? And these are the two parts. You will have half of the pattern here, half of the pattern here, and you need to, basically, you should be able to close and open it. Now, these two parts are called cope and drag. Cope is the top part, drag is the bottom part. By the way, we'll also come to classification of casting, and not all of the casting processes involve two-part molds, but this is the most common one. Okay, so cope and drag. What else? Sprue, you can see where the metal goes through, that first channel, the wider channel, that is the entrance of your metal. That is known as the sprue. Then the runner, again you can see in the image, runner is the channel that directs the metal towards the mold cavity or pattern cavity. It's pattern cavity actually, you can also call it mold cavity. Gate again is this thinner channel. By the way, why do we make it thin? Why not just have the same runner kind of diameter? We make it thin because you will see, after we have fabricated our structure, we need to break it, and it's easier to break it using these thinner gates. You will see. Okay, so gate is something you understand also. Riser is this channel where the extra metal, so when your cavity is completely filled with the metal, you will still keep on pouring a little bit more, and then the extra metal, little bit of extra metal will go into the riser. Why do we need that? Because when your metal solidifies, it is going to shrink a little bit. because any liquid converts into a solid, atoms come close to each other, there is some shrinkage. Now when this shrinkage takes place, then because of the shrinkage there will be some cavity created, some gap created, and there from the riser some metal can come back and then fill that cavity so that you don't have holes in your structure. So that is the job of riser. Of course, also it displaces the air out. And that is, so this is now a more or less complete design of a casting mold. Okay, flask by the, so flask is this very outer dark black lines you can see. Flask is the big pot in which you're doing everything. So that is known as flask. So these are all different definitions. After solidification, I said that all the extra material we remove. Maybe this becomes more clear with this picture. So actually, you're not going to get just the cross which you saw in the previous slide. What you're going to get after you remove the mold is something like this. It will be the structure that you want to make, the part that you want to make, plus some additional metal, because also the metal, the extra metal in the sprue and riser, all of that will also solidify. Metal solidifies very fast, especially if you're performing the casting at room temperature. So if you take aluminum, for example, it melts above 600 degrees, and what you need to do is you need to actually heat it a little bit more, so around 700. So you have superheated aluminum, and that superheated aluminum you pour inside the cast, and within seconds it's going to solidify. Okay, and then it's also going, because the room temperature is so much lower than the actual temperature of the metal, right? So you're going to have everything solidified. So you will have also the extra metal in the riser and in the other part, the sprue, everything. So this is what you're going to get, this orange color structure. This is how your structure will look like, and now you will break it on both gate kind of structures. That is the reason we made them thin, so it's easier to break it from there. And then all of this extra metal, what are you going to do with this? You're not going to throw it away. Metals are reusable, right? So in your next time you melt your aluminum, you will just put this metal back there, so it's not wasted. But this is basically the idea. This is how a more or less complete the cast molding cast looks like. Casting mold. Okay.